we are going to do the experimentation part of how to connect two solar panels of same rated. Okay, so this is an 80 watt peak solar panel, this is an 80 watt peak solar panel. Already in the analysis part we discussed these two solar panels we are going to connect in series connection. Already the system voltage I may require 24 volts, this is 12 volts and this is 12 volts, then how I have to connect them? Series connection. Therefore the resultant voltage is 24 volts. So you see here, so actually we will not bother about open circuit voltage and short circuit current, we will bother only Vm and Im, where Vm and Im are the maximum voltage and maximum currents of the two solar panel. So we selected two solar panels of same rating. First experiment we are doing same rated solar panel. Next we will interconnect one 80 watt panel with one more 100 watt panel. So when you turn this nameplate details, you can see at the back. So what is the maximum voltage it is going to develop? V maximum is 17.25 volts. Okay, so this solar panel is generating how much voltage? 17.5 volts. So that solar panel is also generating how much? 17.5 volts. Take it as 17 volts and 17. Okay, so now 17 plus 17 is how much? 34. Is 34 volts is the system voltage or the array voltage. I am having a string inverter that requires how much voltage? 34 volts. Now how I have to connect these two solar panel? In series connection. So we are going to verify for you, making the things more clear. So I am taking one solar panel and I had connected to the positive terminal and negative terminal. What is the Vm of the solar panel? 17 volts. You see here it is showing it as 17.5 volts or approximately 18 volts it is showing. That is reaching which value? It will not show VOC, actually it has to show which value? VOC, but we are connected to the load, that's why it is not showing. Okay, so let us take that this is connected to the, it is showing some 18 volts, and from that side we are taking the voltmeter and we are also connected this in which connection? Series, I mean parallel connection. So this voltmeter and this voltmeter are connected in parallel to the solar panel. So in order to make you to understand well, I will show you the diagrammatical analysis. So we have an solar panel like this. What are the outputs of the solar panel? Positive and negative. So what is the output voltage of the solar panel? 17 volts. We are connecting one voltmeter with positive terminal as well as negative terminal. What is the rating of the solar panel? 80 watt peak. And I am taking an one more solar panel, and what is the rating of the solar panel? 80 watt peak, and I am connecting a voltmeter in parallel. So now resultantly I want to measure what is the resultant voltage. Now what I have to do now? Series connection means what? Connect the negative terminal to the positive terminal. Ultimately you are getting one positive terminal, ultimately you are getting one negative terminal. Here I am connecting an voltmeter. Okay, so I want to measure the current also. Okay, so you can see what is the maximum Vm is how much? 17 volts. What is the, I will already calculated. What is the Im value? See the value of Im. What is the value of Im? 4.7 amperes. So current will be multiplied or same value? Current is same. In an series connection, the same current will flow in this branch, but it will not be 4.7. Why? We already connected for a protection. We connected an wire wound coil. Okay. Now let's try to verify. So this voltmeter we connected. What is the voltage indicated in this voltmeter? Approximately 17.5 or approximately 18 volts it is indicating. And how much voltage it is indicating? Approximately 18. So now 18 plus 18, how much? 36 volts will be indicated by this voltmeter. So you can see here this is also connected to 18 into 2. Why? Because here we connected to the tapping of 60. So when you connect to the tapping of 30 and 30, this is scaled, lower scale you will get into consideration. Okay, so this is nothing but 18 volts and 18 plus 18. So resultant voltage is also 18 into 2. There's nothing but 36. You can see all the readings are in the same value. Okay, so all the readings are 18, 18, resultant is also 18 into 2, 36. So it is connected at 18 and it is scaled with how many times? 2 times. Why? Because we have the 2 tappings, we can connect for 30 volts and 60 volts. So now up to here we verified the voltage of panel 1, voltage of panel 2, and after connecting what is the individual voltage. Now after connecting we are going to connect it to the load, and we are connecting one ammeter, and we are going to connect one wire wound coil, and we are keeping an maximum resistance position. Okay, so here you can see the connection how we have been connected. So we have taken one tapping from there and we are connected at the input. Okay, so we have taken the input, we are giving some basic protection, fuse protection, and we connected to the ammeter input. Output of the ammeter we are connected to the resistance input, I mean wire wound coil input, and we are taking the output and we are connecting to the load. So ammeter and wire wound coil are connected in series. Okay, so for safety point of view, we used an inductive coil. Okay, so now you see here how much current it is showing. So now 17 resultant it will be showing as how much, 34 volts, or 18 36 volts. Okay, so now you see here I am varying the current. So now the current is 0.5. so as soon as I come closer, you can see here the current is increasing. So maximum current we already done the experiment, how much, 4.7. so now it is showing approximately 1 into 2 amperes it is showing. And you see here 2 amps means is already consumed, the remaining 2 amps is available as in this load. Are you able to understand? So half load is consumed here and remaining half is indicated in this meter. Okay, so you should not bring it to minimum. If you bring it to minimum, what will happen? This wire wound will start burning. Okay, so that's why we are not bringing to the minimum value, and we are trying to put the resistance in which position? Maximum resistance. Therefore this is the input and this is the output to completely the load. What is the load? You can say now 80 plus 80, how much? 160 watts. 160 watts of power is consumed between these two terminals and is equal to a bulb. If you connect a DC bulb to that, now it will work. But DC bulb of how much rated it should be there? What wattage is not required? What is required? System voltage level. What is the voltage level? It should have 24 volt system. You think if you buy an DC load type, you have to check the system voltage. It may be 12 volt system or 24 volt system. Okay, so that's how we are doing the connection with identical rating. Identical means same rating. So now voltage is multiplied how many times? 2 times. So what is the array voltage now? 36 into current is how much? 4.7. Then you will get automatically how much? Approximately, if you do the product, you will get 160 watts or 170 watts. Okay, so 80 plus 80, now power is increased how many times? 2 times. Why it is increased 2 times? Voltage is increased how many times? 2 times. Therefore now we are connected to a load of how much watt? 160 watt. We will perform the second experiment with different rating, and you will see the deflections in the voltage and currents and how it is going to affect. Okay, so after completing, you have to keep the resistance in which position? All the time you have to keep in maximum resistance position. If you keep in maximum only, the load will be applied to the terminals. Okay.